This is past paper 2015, paper 2, question 4. Two circles, this S, two circles S and C. So that's S and that's C, that little one there. Touch and turn at B, so they touch there. The equation of the circle S, this big one, is x minus 1 squared plus y plus 6 squared is equal to 360. Write down the coordinates of the center of S, right, this point here, and then write down the radius of S in the form of a root 10, where a is an element of n. So, for the situation here. So we've got this here. So that's S, and that's there. And they gave us the equation x minus 1 squared plus y plus 6 squared is equal to 360, and you've got to get the cent. That's for S. That's S. That's the equation of S. This whole thing here, and they want the center of that and the radius of that. Now, looking at that, you can pick it out fairly quickly, but I'm going to convert it into the other form of a circle. That's one form of a circle. Okay, this is the other form of the circle, and you can do it either way. So I'm going to convert it into this form at first and then work back, just so you know. Really, you should be able to just pick them out from here, but in case you're not familiar with that, I'll do it the other way. So we've got x minus 1 squared plus y plus 6 squared is equal to 360. Square this, you got x squared plus 1, squared first, squared a second, x squared plus 1, twice the product, minus 2x, and then you get square the first, y squared, square the second, 36, twice the product, 6y, it's 12y, is equal to 360. So x squared, bring the y squared over, minus 2x goes to there, the minus 12y goes there, you get minus 1 plus 36 is, no, that's plus 1 plus 36 is 37, you get 360, then you get the x squared, the y squared, minus the 2x plus the 12y, plus the 37, and bring the 360 over, you get minus 360, and then you get x squared plus y squared minus 2x plus 12y, and then you get minus 360 plus the 37 is minus 323, and that's equal to 0. So I've just moved it into a different form, and now then you use the 2gx. This is the technique. 2gx is equal to the x component, not the x squared component, but the x component. Put down the whole thing. So 2gx is equal to minus 2x. The x's cancels, the 2's cancel, you get g is equal to minus 1, and minus g is equal to 1. Now minus g is what you need, not the g, so you'll get minus g. That's the technique. Minus g is equal to 1, so that's the first center there, which is the x coordinate 1. G is the x coordinate, right? That's they use g and minus f for circles, but really it's the x and the y coordinate, right? So g is minus g is 1, therefore you write down 1 there. And then you do the other one for the y part. It's 2fy is equal to 12y. That's not the y squared, that's just the 12y. 2fy is equal to 12y. Y's cancel. 2 goes into 12 6 times. F is equal to 6, therefore minus f is equal to minus 6. So what you put down for the center is minus 6. Okay, so you've got that, and then as the part of the formula, the radius is equal to g squared plus f squared minus c. Now we have g, which is minus 1, so we can put that minus 1 squared, and we have f, which is 6, so that's 6 squared minus c. Now the c is minus 323, so it's minus 323. Okay, that's part of the equation, don't forget, and the c is taken directly out of here, the whole thing that goes in there. So you get minus 1 squared is 1, 6 squared is 36, plus 323, that's the radius, and that's equal to 360. That's equal to the root, that's square root of 360, right? And that's the square root of 36 multiplied by 10. 36 multiplied by 10 is the same thing. Take the 36 outside the square root. You can do that since they're multiplied together. You get 6 root 10. So that's the radius of this from there to there, 6 root 10. Now, if you notice that what we got was 1 and minus 6 and 6 root 10. Now, if you're given the equation of a circle in this form, you simply can take out the center by observation. You essentially get this component, which is right next to the x, and flip the sign. So minus 1 becomes 1, so minus g is equal to 1. It's expressed as minus g. So it's minus g is equal to 1, so it's right there. And flip this sign, you got plus 6, and then you flip it to minus 6. So minus f is equal to minus 6, right? So you have it already. I just converted it so you can see the difference. And then the constant part, you just take square root of that. So it's the square root of 360, which is equal to 6 root 10, which we just figured out. But you could have done it much quicker. But now you know you can go back and forth, and you'll use this format when you're getting the equation of the circle. Right, I'll come to that in a second. But that's 6 root 10 is the distance from there to there, and 1 and minus 6 are the coordinates. The point K is the center of the circle. That's K there. Okay. The radius of C is 1/3 the radius of S. So that whole thing is the radius, and this radius is 1/3 of this whole thing. So if the whole thing is 1, that's 1/3, and therefore that's 2/3, because 2/3 and 1/3 is 3 out of 3, which is 1. So that's 1 out of 3, and that's 2 out of 3. So it's splitting it into a ratio, which I'll come to in a second. So the coordinates of B are 7 and 12. Find the coordinates of K. So you have here is this thing from there to there. We just figured out was 6 root 10. And they said that the distance from there to there was 1/3 of that, right? So it's 1/3 of 6 root 10, which is equal to 1/3 multiplied by 6 root 10, which is equal to 2 root 10. So that distance from there to there is 2 root 10. Okay? And they said that, and that way I'm going to come to that. I'll use that piece of information in a second. I don't need it just yet. They said that the radius of this is 1/3 the radius of the whole thing. So if you've got, like, let's say this line here is here, I'm going to put it here. So you've got, that's 1/3 of the whole thing, and that's 2/3. Therefore that's 2/3 the whole thing. So that, if you cancel out the commons, you get the ratio, which is 2 to 1, right? That's the ratio that they're splitting. So you're using the bisector of a line segment formula. Okay, so that's 2/3 of the whole thing, and that's 1/3 of the whole thing. Therefore, that's 2 to 1. Okay, so subtle point there. Cancel out the 3's, and you've got it, right? So that's an important point there. So let's say I'm going to write that line again down here. So we've got a ratio of 2 to 1. We've got our point there. Now we're trying to find this point here, which is our x and our y, which corresponds to this here. Okay, so this line is 2 to 1. Right, I got it there, 2 to 1. Now the way you do it, you write it down like this. You got 1 and minus 6 at this end, 7 and 12, which is this thing here, 7 and 12, 2 to 1. You need the x and the y. The way you get the x coordinate, and this is a quick way of doing it without having to write down formulas. Write down, and now we're dealing with the x values only. You'll take the first one, 2 multiplied by this one, plus this one multiplied by this one. Now these are the x coordinates, so it's 2 by this x coordinate plus 1 by this coordinate, moving this way. Okay, from left to right, 2 by the x, 1 by this x, 2 by this x, and 1 by this x. So it's 2 by 7 plus 1 by 1, 1 by 1, and then over this 2 plus 1. Add the two ratios, 2 plus 1. So you get 2 by 7, this is 14, plus 1 over 3, which is 15 over 3, which is equal to 5. So the x coordinate is 5. Now you do the same thing for the y coordinate. You go 2 by the y coordinate plus 1 multiplied by the y coordinate. So it's 2 by the y now, 2 by 12 plus 1 by this one, which is minus 6. So 2 by 12 plus 1 by minus 6 over, and add them. 2 plus 1 is equal to 3. So you get 2 by 12 is 24, minus 6 over 3, which is equal to 18 over 3, which is equal to 6, 5 and 6. So that point there is 5 and 6. And that's the coordinates that they were looking for, right? So find the coordinates of K, and that's 5 and 6. And then they want to find the equation of C. So you want to find the equation of this here, okay? So first of all, we need to get the radius. This is C here, right? We need to get the radius. Now, they said that the radius of C was 1/3 the radius of this large thing. That means that the large radius of S, that was 6 root 10. So it's 1/3 of 6 root 10. This is 1/3 multiplied by 6 root 10, which is 2 root 10. So this radius was 2 root 10. So you have a radius and you have a point, and therefore you can get the equation of the circle. And you do that using the following formula. You go x minus x1 squared, where x1 is the center, plus y minus y1 squared, where y1 is the y coordinate of the center, and that is equal to the radius squared. Okay, so we have our center, which is, as we figured out, it was 5 and 6. So that's 5 and 6, and so you go x minus 5 plus y minus 6. That's x minus 5 squared, y minus 6 squared, and the radius squared. And the radius is 2 root 10. So it's 2 root 10 squared. 2 root 10 squared, you square that and you square that. That becomes 4, that becomes 10. It becomes 40. And you've got x minus 5 squared plus y minus 6 squared is equal to 40. That's the equation. Right? And you can, again, since we created this equation using this formula, I simply put the x and the y coordinate into there, and then the radius, so you know that they're interchangeable, which is what I did at the very beginning. So that's the equation of C, and then find the equation of the common tangent at B. Okay, so that's the common tangent, so the equation of this. So what I'm going to do is I'm going to get, now in order to get the equation of a line, you need a point and a slope. We have B, we know at B that B is 7 and 12, so we have a point on this. If that's let's say that's the tangent, we've got a point B on that. All we need is the slope of this, but we don't know that. But we know that it's perpendicular to this one because that's the radius, and that's what they say, it's a tangent. So it's a tangent to this line here. So we get the slope of this, and then invert the slope, you'll get the slope of this. So you've got a point and a slope, and then you can get the equation. So we've got the 1 and minus 6 and 7 and 12, right? So I'll get the slope of this line here. This line here, so it's 12 minus, that's minus 6, so it's 12 minus 6. The minus is part of the formula, right? Don't forget that, and so is that one. So it's 12 minus 6 over the x ones. It's y over x for the slope, right? So over 7 minus 1 over 7 minus 1. So you get 12 minus 6, which is 12 plus 6 over 7 minus 1, which is 6. That's 18 over 6, which is equal to 3. So the slope of this line is 3. Therefore, the slope of a tangent to this, which is a common tangent, that's a right angle, that'll be, you turn it upside down. You got 3 over 1 becomes 1 over 3, and then change the sign. So it's a minus a third. 3 is 3 over 1. Turn it over, 1 over 3. Change the sign, minus 1/3. Okay, so you get slope is equal to minus a third of this, and we have a point on the line. So we go y is equal to mx plus c. Fill in all that. We need to get the value of c. So we get y is 12 there. Okay, y, that's y1 x1. That's y is 12. M is minus a third, and 7 is this coordinate here, 7. Plus 6, so you multiply across by 3, you get 36 minus 7 plus 3c, multiply across by 3, and then you get 36, and this minus 7 comes across, you get 36 plus 7 is equal to 3c, 43 is equal to 3c, and therefore 43 divided by 3 is equal to c, right? So then you go back to the equation here, and you just use the general form of this as y is equal to mx, y is equal to mx plus c. We know c and we know m, and there, that's your formula, right? You just got to get c. So y is equal to minus a third x plus c, which is 43 over 3. These are variables now, and initially to get c I put in a point, but now these could be any points, so that's why they have to go back that way. Multiply across by 3, you get 3y is equal to minus x plus 43 bring this over and this over, you will get x plus 3y minus 43 is equal to 0. That's it.